Hey everybody, John with Owl. I've got a fun one. At least I'm excited. Now, I actually don't know how this video is going to turn out. I got a pretty good idea, but obviously I haven't done it yet because we're going to do some destructive testing. That's right, we're going to wreck some stuff, including an Owl tire carrier. Well, maybe. We may wreck an Owl tire carrier, an Expedition tire carrier, much like this one. We're also going to maybe wreck some other tire carriers that aren't made by us. Why am I doing this video? Well, we try to stay away from talking about other people's gear. But as the van market has become more and more saturated and more companies are jumping in, I think it's really important that we take the time to walk through what it is about Owl products that we work so hard on and we feel makes them so much better than what else is out there. Obviously, this video is going to be biased. It's going to be biased because me, John, Owl, is doing it. But what I'm going to do my best to do is present to you some objective information and objective tests that will allow you to make your own conclusion about the quality of the different products on the market. I think the best place to start is materials. Materials are not all the same. They're not created the same. They don't cost the same. They don't weigh the same. This, aluminum, lightweight, somewhat soft, very, very, very difficult to work with. So aluminum has a cost. Steel, I love steel. Steel's an amazing material, incredibly easy to work with, very forgiving, cheap. There are a lot of amazing advantages to steel, and if anyone out there wants to start working with metal, steel is the place to start. Steel has some disadvantages, however, and that's weight, rust, you know, all these different types of scenarios. So you've got some advantages to aluminum, you've got some advantages to steel. There's also methods in which a product is, I don't know if manufactured is the right word, but machined, welded, cut. All those have an effect on the end quality, and all of those have different costs. So anyway, we're going to have a little bit more fun. Now that we've gone over the different materials that you can use in these products and the advantages and disadvantages of each, you will notice that this is fairly obviously aluminum. You can tell by the color, just like these parts that I have right here. All right, aluminum's got this different color. The other thing, you notice there's no rust on these parts, right? Aluminum doesn't rust. It can get an oxidation layer on it. It can corrode slightly, but it's not like steel, where something sitting out in the sun and weather and rain will eventually rust. In fact, does this have any rust on it? Yeah, just a little bit. This is just a part that we have for an old product. It's got a little bit of rust spots on it. So we've talked about materials. The other thing that we want to talk about is design, and angles matter. How things are put together matter. Everyone knows from, how do I want to do this? Well, we'll do it with these. We've all heard of I-beams, right? Okay. What's stronger, a flat piece of metal or an I-beam? A board or an I-beam? Well, the answer is an I-beam. And why is that? Well, when you've got a flat piece of metal like this, in fact, this was bent in a press brake, it bends fairly easily. Everyone knows this. If you were to take a piece of cardboard that was bent in four, or even this aluminum, now this steel is stronger, pound for pound, than the aluminum. But see how this is boxed in? You've essentially created half of an I-beam. Now if you try to bend this, damn near impossible. You try to bend this, a whole lot easier. In fact, this right here is essentially a spring. Look at the leaf spring of your vehicle. It's kind of like this, right? It's meant to flex and to bend. And when you simply have a piece of steel that's curved, it is a spring. This, on the other hand, is meant to be incredibly rigid. It's meant not to bend. Why is that important? Well, when you look at the way Owl constructs its products, we use that hinge, we box it in. So let me take you with me here for a moment and show you how we do this. All right, so you see how we box this in? Why is that important? Well, it's important in how the carrier is held onto the vehicle. It's also important when it comes to how much flex you're going to get out of this. Why is flex important? Again, I talked about two things here, and of course I can't open the door right now because I have, you know what I call this? This is the Tire Carrier Test-O-Matic 3000. That is a very scientific name. In reality, it's something that I welded up in about 15 minutes because I needed something heavy, aka the Owl Ultimate Beast, to offset the poundage we're going to put on these tire carriers. So again, going back to why is this important? Well, it's really important that we stop rotation of this mass into that third mounting point. You've got two mounting points, hinges, incredibly strong. So this is the first area of note. You do not want anything that attaches to the door. Owl invented this stuff. If you don't believe me, go back and watch the Owl origin story. Go back and watch some of my personal YouTube accounts where 3.5 years ago I was pioneering and prototyping all this stuff while recording it all. So if it's out there, a no-drill solution, a solution that mounts to the door, a solution that has a hole here, a solution that has a hole there, chances are we tested it. And the reason we went with the methods that we have is because in all of our destructive testing, that's right, we destroyed a lot of van doors that we purchased from Mercedes to make sure that we had the best possible product. And in the midst of that testing, we tried a lot of different scenarios and they didn't pass, they failed. So that's how we ended up here. So you're gonna have to take my word for it, but the way we do it has been problem-free for many, many years. And the reason is because we tested the other methods and they fail. The other misnomer about the quote-unquote no-drill systems that attach to the door, they're not no fabricate, they're no drill. What you end up doing is drilling a single hole through to an incredibly strong piece of structure behind the door in exchange for cutting weatherproofing in the door, which compromises your waterproofiness, that's a technical term, as well as grinding down latches that hold the door closed. So 6 of one, half a dozen of another. It can be no drill, but it's not no fabricate. And I think that's a little bit of a misnomer, so I'll call them out on that right now. Now, getting back to rotating mass. You've got a van door that is fairly thin sheet metal. That was never really intended to take a load like one of these products. And so what we want to do is, these hinges are incredibly strong, right? In fact, there's all kinds of videos where we lift the van on those hinges, so those are incredibly strong. Third mounting point, not very strong. And so when you slam the door with 100 pound, this 35 is easily 100 pounds with the wheel. You want to stop that mass rotating into the door. Now the way we do that is, again, with this boxed in hinge. Now I can talk a little bit more about how we preload our carrier, and what that means is we actually engineer it to be slightly off the door on the third mounting point so that when you tighten the bolt, you're actually sucking the carrier into the door, which puts a little bit of flex into the carrier, or preload as I'll call it, which means that the carrier is not going to impart as much force onto that third mounting point when you slam the door. The other thing working to our advantage, look at the angle of our welds. They're actually wrapping around. You have two welds that wrap around the tube horizontally and the hinge is boxed in. We talked about I-beams. This hinge is incredibly rigid and doesn't really bend. By grabbing the tube this way, it's incredibly strong and it stops the tube from rotating, okay? When you slam the door, it doesn't rotate. Why is that important? Well, if I were to take this little piece of metal I had before and I were to replace that boxed in hinge with a piece of metal like this, when you slam that door, this is gonna flex. And what that means is you're gonna put load into that third mounting point. What does that mean? It means that over time you're gonna split your door, hands down. The reason I know that happens, why do you think Owl carriers don't have an inner door plate? Why do you think other manufacturers require putting in a steel brace onto the inside of the door with their carriers? It's because they didn't understand this, and they didn't understand that what you've created here is a spring. It's meant to flex. So when you slam your door, you're going to get this flexing, which means all that 100-pound tire is going to be pushing in that third mounting point, and you're going to ruin your door. There's a reason that Owl carriers don't need inner door plates. It's because of how we designed this hinge system. Now I want to visually show you that difference. This is where it gets kind of fun. Again, I don't know what's going to happen, because I know you know these tire carriers are not cheap. And I'm not in the business of throwing money down the drain. So we're going to destroy a $1,200 tire carrier. Maybe it's even more than that these days with inflation. We're going to destroy a tire carrier to show you how strong it is. And the way we're going to do that is this. I'm going to set this off to the side. Oh, wait, one other thing that's really important. This is aluminum. It's lightweight. I think this main structure here that we're about to test is like 11 pounds. This, by taking that weight out, that's less weight on your door, less weight every time you open and close the door, less weight physically to open and close the door. So weight, again, important. Aluminum is very light. Now, what I've set up here with the Tire Carrier Testorama 3000, I'm not sure if I got the same name right from earlier, but with the Tire Carrier Testorama 3000, what we're going to do is we have attached the tire carrier rigidly to this steel carrier that I've essentially created. And the purpose here is, this is your third mounting point. So what we're going to show is how much weight those hinges can hold before you start to get some deflection or some bending in this carrier, which is essentially an example of how much weight you're going to put into that third mounting point. So what we're going to do is stack some weights on it. So if I go over here, we put this post on here, and we're just going to stack weights, and we're going to see how much weight this thing can handle before it starts to bend and deflect. I don't know what we're going to get to. I have no idea, but I brought a lot of weight, so we'll see. All right. I also kind of like this because, again, talking about when I first started designing this carrier, I used these exact same weights almost 4 years ago, 3.5, 4 years ago, to test my original tire carrier. So I think it's kind of fitting that Al has come a little ways, that I'm going to be testing our tire carrier with this same weight. All right, so 45 pounds. Drum roll, please. All right, 45 pounds. Now, I don't know how much this tire carrier can take, so I'm going to step it up. This is another 25 pounds. So I'm going to do this in my head. I'm going to get my gazuntas going. We got 45 plus 25. You add 5, that's 30, plus 20 is 50. No. Plus 5 is 50, plus 20 is 70. Good Lord. Can I edit that out to make myself not look as dumb? All right, so now we got 70 pounds. Holding firm. Let's get another 25. $70 plus 25, $80, $95. All right, we're still there. I'm going to take those off, put a 40 and put the 25. We'll take this off and we'll put a 45 on. We're looking at 115. 115. Can we go another 25? 115 plus 25, you got 20, 140. I got to be honest, I don't know if I left enough peg on that. So, all right, we'll take some of this, we'll restack and add another 45 in place of some of these 25s. Okay. Let's put another 45. 40. 160. All right, so you can see right now we have 160 pounds held on by just those hinges, supporting 160 pounds of load. It has not bent or moved. Nothing here is bent, nothing here is breaking. All right, so instead of breaking this, let's put a competitive tire carrier. Now, I don't want to say any other competitors' names, so we're not going to throw them under the bus by name. We're going to put another tire carrier on there, and we're going to see if it can get to the same weight as an owl carrier. All right. Here's the other tire carrier we're going to test. Now, first of all, I think it's important. We talked about materials. We didn't talk much about stainless steel. Stainless steel can be a great material because it is fairly rust-proof. It's not 100% rust-proof, but fairly rust-proof. Now, it's great against corrosion. It's terrible as far as strength. Stainless steel is a very soft material. Now, the maker of this tire carrier says that it's manufactured from stainless steel. It's patently not true. You wouldn't even want to make it from stainless steel if you did. And then to make it of stainless steel and then powder it kind of doesn't make a ton of sense. But it's not made of stainless steel. I would know that right off the bat because it wouldn't work. But even, see this? This came off a customer's vehicle. They came in to swap it out. You see that? That's a part that got nicked. I don't know why. It's rusting. So case in point, not stainless steel. More rust there in the holes. You can see that. I don't know if you can. Anyway, my point is, don't necessarily believe everything you read online. Whew, picked a hot one to do this today. This is a little plate that we made to hold the weights. Now, arguably apples to apples, I will admit that this probably weighs, I don't know, 3-4 pounds, maybe probably 2-3 pounds. It is nice to have your own fabrication shop at your fingertips. It makes little changes like that easy. Just already you can see how bouncy this is. I don't know how well that's going to fare. All right, here we go. So we've got the carrier, we've got this thing, which again, probably 3 pounds. So we'll spot this carrier 3 pounds. The first 45-pound plate going on. Next 45-pound plate. Next 45-pound plate. Whoa. All right, well, there's your answer, my friends. So what were we at? We were at, I have to look back in the video, but I think we had another 25 pounds on the owl, and arguably it could have kept going. It certainly didn't fail. So, see what I mean about that essentially being a spring? So you've got that happening. So why is that important? It means that every time you close your door, that is putting more force into the third mounting point. Oh, almost tripped over a weight. Into this third mounting point, which means that eventually you're going to have problems. All right, so I almost never reshoot videos, but this has really been bothering me. I did this whole test yesterday with the different tire carriers, but we never took the owl carrier to failure. And I thought, I want to see how much it can hold. And I kept thinking about it, and I don't know. And so I'm like, you know what? I already shot the video, but I'm going to set it up again, and I'm going to put that same tire carrier back on, and we're just going to load it up till it fails. So let's see how high we go. All right, so the other tire carrier failed at this weight, which is 130. All right, so now we're going to go up to 180. There we are at 180. Can we get to 200? Let's see if we get to 2 bills. This is a 25. It's going to put us over 200. You have to balance it here. All right, I had to get a little inventive. I took a strap and I strapped the weight on. It's not strapped to the steel mount, just for clarity. I've just strapped the weight down to the carrier. So now hopefully we can stack a couple more plates. All right, 45. Bueno, 25. There we go. Now we're starting to get it. Should we go for another 25? That is literally all the plates I have. So we're at 45, 90, 180 plus 50. We're at 230 pounds. 230 pounds. So that's 100 more pounds than where the other carrier failed. Look at this. I don't even know how much more it can take. These hinges, no bending. Everything looks fine. Everything looks fine. Nothing. It's crazy. I love it. Problems. So I did this to show you that when we manufacture these things and when we design these things, the point is to make the best possible gear. That carrier is less expensive than an owl carrier. Maybe it has free shipping. I don't know. But the point of it is you can have something that'll work for a while, but if you want something that has been tested for years, we have literally millions of miles now between all of our customers on our carriers without a failure. And we pioneer this stuff and we work our butts off to make sure it's quality. So again, I felt a little bit uncomfortable making this video because I'm not in the business of denigrating other people's products, but the point is to show the difference between what we do with our carriers, the time, the effort, the engineering that goes into these to make them what I think is the best product on the market. And I wanted to show you that somehow demonstratively so that you could see the difference. Again, this carrier, half the weight, this frame is half the weight of that frame, and look at what happened. Stronger. That's all I got to say.